Yeah, thanks. Thanks for joining me at the end of today. So yeah, we're going to have a little bit of fun because we're going to hack, well, this jump rope there. I even promised I'll be jumping. Well, a little bit, okay? So there we go. I'm actually, well, my job is not to be a professional jumper, right? I'm a malware researcher. I work with Fortinet. And I usually work on reversing mobile malware or IoT malware. Okay, so this is more on IoT, although there's nothing malicious with this presentation there. I'm also the organizer of a CTF, which is called Phone, and which is dedicated to connected objects. This one is in the south of France. So today we are going to do two different things. First, we're going to hack the communication protocol of this jump rope. And the second part is that this was actually part of a challenge at Phone in a previous edition. And we're going to see how we can create a challenge and what are actually the challenges to create a CTF challenge when it involves such a device. Just a little bit of presentation on the jump rope itself. It's pretty simple, okay? So basically you just like jump with it, and the intent is to stay fit, let's say. And with this jump rope, there are three different modes. You've got first the free jump mode, which is, well, you just jump and it works, okay? It counts how many loops you've been doing. The other one is you say, I want to do an exercise for, I don't know, 10 minutes, okay? And it's going to tell you how much you've been jumping during that time. And the other one is kind of the opposite, is you say, I want to do, I don't know, 1,000 jumps. Tell me how long it took me to do that, okay? So those are the three modes that you have on this device. Now, usually when we start hacking any kind of connected device, what people like to do is to look into its hardware. I started this research actually at the beginning of the lockdown. And at that time, well, it was difficult, at least in France, that sometimes we were locked down at 5 kilometers around our own house, so we couldn't go out very much. So I thought, well, okay, the jump rope is going to be kind of a good device for me to stay, or to try and stay a little bit fit. And I said, okay, I'm going to buy one. And then I went on to, I think it was Amazon, and I saw that to buy my jump rope, I could get a connected one for like 2 or 3 euros more. I said, this is going to be interesting. I'm going to buy the connected one, okay? But I needed it, so I didn't want to tear it down. I mean, I wanted it to be still functional. So in that case, I'd say that without opening the device, the website fcc.io, I'm sure that many of you know it, is your friend, because you basically get to see the application forms of the product and what is inside the product without even having to get a screwdriver or anything at all. Okay. So in here, what you see is, well, you see the LCD screen of the jump rope. There is a single button which controls everything. And if you had looked on the other side, you'd see that there is a single chip, which is a chip from Beacon. And it actually handles all the Bluetooth communication, because this jump rope is communicating with a smartphone using Bluetooth Low Energy. Okay, and then there's another small board, which is actually put perpendicular to the other one, which actually has the sensors on it. So I believe that this part there, this one there, and this one there are actually what they call the 3 Hall sensors, which are sensitive to magnetic fields, if I'm correct, and which will actually count how many loops you've been doing. And this is taken from, well, the advertisement of the manufacturer, which shows what is inside the jump rope. We're talking about, because it it's a little bit important for that, for something which is around 20, 30 euros. Okay, so it's not meant to be kind of high tech and everything. It just works, and that's perfect for what it is. Now, where can you hack this from, knowing that we want to hack the communication protocol? Well, if you're into hardware hacking, you can certainly do lots of hacking from this point. You can get the firmware, for instance, and reverse the firmware and modify things or customize it, add your own firmware or things like that. It's possible. I find that a little bit more complicated than what I'm going to present today. The other possibility is, of course, to hack at the communication level, okay? Because we said we wanted to hack the communication protocol. So we can sniff Bluetooth packets and get that and analyze that and understand how it is working. This works, but you need special devices to sniff Bluetooth low energy, such as Ubertooth. I guess that many of you have already heard of, and let's jump to there. Actually, I find the other one, Adafruit's BLE sniffer, less expensive and maybe, well, it's good for the task. I've already used it. But today, we're going to see another option, which I believe is actually quicker, easier, and less expensive because you don't need any equipment at all, well, besides your smartphone, is that you're going to hack everything from the smartphone itself. And let's say that it's kind of the key thing to remember about the talk, because actually working on the smartphone application for many other devices is a really good way to start your hacking or to help you into hacking those connected devices. So those are all devices that I have hacked previously. Some of those actually I presented in a previous talk at Troopers a couple of years ago. And what you see is that there's always app, and app. Well, it's also because I happen to be reversing mobile malware very much, but it's really convenient, as you're going to see. So what's extremely convenient in this part is that actually we're going to see the Bluetooth low energy packets in Android system logs. We won't even have to sniff anything. They will be just directly on the system logs of Android. And this is what you see in there, okay? This part there, hex something, and then the packet. This is the Bluetooth packet, which is there. And the name tag here is the name that the application which is handling the jump rope decided to give to its tags. And there, so if we just listen to everything with the name tag, well, we see all the logs that we are interested in. Now, this is where I'm going to show you that live. So, this is my smartphone. I'm going to go to the application. Deny. And it's not here, it's this one. Okay, and I've got to connect. Yeah. There you go. Device is there, and I'm going to connect to the device. Okay, we're connected. I'm going to put that on one side over here. And we're going to do logcat over there. So here we see everything which is sent by the application, okay? And well, you can see that turning live normally. And that is, I'm gonna untie a little bit myself, okay? So watch the logs. Okay. Thank you very much. Actually, I can do that longer, but it's not the point of the talk. So, is anybody fluent in Chinese? Because everything is in Chinese, so this is actually the most difficult part, because you've got to, for me at least, because you've got to go to Google Translate everywhere to understand what is happening. But actually, it's pretty well detailed, which is good. I'm going to show you again. So the hex packets. Oh, we've got one here. Okay, so this is a Bluetooth packet. And by the way, this one was interesting because, well, you know, I'm fluent with Chinese now. So this actually means something close to battery level. Okay, this is actually how you can start and understand the code. Okay, so now we're going into a disassembler. I am going to have a look at the source code in there. And, sorry, I go back to the logs. And I'm going to copy-paste this. And I'm going to search for it while pasting it into the disassembler. And there we go. We find something which is actually named, by the way, update battery. So this is Dalvik disassembly. Maybe you'll find it easier to read with something which looks like Java. And there we go. So this is what we have. This is the line that we see actually in the logs. And we see that it is actually updating the battery level for the application. So most probably, my battery level is currently 70%. If we have a look at something else, well, we can try this one. This is actually a wild try. I'm not sure this is going to give anything else, anything good, but I'm going to copy this one. Yeah, this one goes. So this one goes in something which is called parse command. And now when you're a hacker, you know that, getting into something which is called parse commands, that is juicy. You like that one. Yips. And so parse command is in here. And what happens is that you see that it's starting actually a thread. And probably the core of the thread is in there, so we're going to go into that one. And it's that. Okay, it's a class. It's a runnable class, which means that actually the core of it, which is running all the time, is in run. And let me show you a little bit what we have in there. Well, we see that we have a CRC check. And then we see checks on specific values. So we can go back to our logs. And we see that, for instance, well, this one was starting with 81. Okay. And if I go there, indeed, 81 is going in here and going to update battery. But if we had had another value, well, we have, I don't know, plenty of other ones, like 83. If it had started with 83, well, then in that case, it would have gone to this kind of stuff. Read offline data. So this is when you jump, but your jump rope is not connected to the smartphone, and you want to get the data afterwards on the jump rope. Okay? So you can do it that way, and that way you understand by just reading the logs and going into the subsequent functions, you go in the right part in the code. And it's far better than just having a direct look at the application, because as you can see, there are lots of classes. So where are you going to start? Okay, you start from what you see in the logs, what seems useful to you, and what is close to Bluetooth packets in there. Okay, let's resume with the slides a little bit. I've explained all of that. So I did that for quite a lot of other packets, and I managed to recover the commands to send to the device to have it do what I wanted to do, like start, I don't know, a number countdown mode, or to set the buzzer on, set the buzzer off, and things like that. And okay, so you've got that. By the way, don't forget that at the end of each packet, you've got a checksum. Okay, that is the CC there. Okay, but a checksum is pretty easy to compute. We're nearly okay with communicating to the jump rope, except we need to know, okay, where are we going to send these packets? So if you're used to BLE communication, this is not going to be difficult for you. Basically, in BLE, every kind of data or entity is a characteristic, and you can say whether you want to read it or to write it. And then those characteristics are grouped into services just to kind of make the thing a little bit coherent. So that's where we're going to have to send our packet to say, for instance, I want to start a jump mode. And then to send the packet on Linux, for instance, well, we can use a tool which ships with the operating system, which is Bluetooth control. Looking into the app, we find the point where we have to send the Bluetooth packet. And let's say that I want to say to the jump rope, okay, please send, I want to start a number countdown mode with 1,337 jumps. Well, this is in hex 539, and you have those there, and then you compute the checksum, and you've got the packet you've got to send. So I'm going to show you that. Yeah, but I'm not going to jump for this one. Okay, and so yeah, this is basically well, you're going to maybe you won't be able to read very well what is on there, but you'll be hearing the beep, hopefully. So I'm connected, and I told you I'm going to do well, this number of jumps. And sorry, yeah, you can't see it very well. Is that better? Okay, you see the number, and it should be starting. And obviously I have the buzzer off, so I'm going to put it on. Okay. And we can start this time a time countdown mode. How many seconds do you want? Okay, we're not going to overflow it, okay, because I know you. Okay, and it starts. And now I've got 600 seconds to jump, okay? But I'm not going to do it, sorry. So I'll cancel it, and that's, well, actually disconnected. Okay, so you can communicate that way with the jump rope. Now, second part is, okay, how do we turn that into a CTF challenge? Okay, What we want people to do, participants to do in the capture the flag, is to show us that they can start a number countdown mode and for 1,337 jumps. So basically they have to work out, well, that's the packet they have to send is that, and send that to the jump rope to get a flag. So first thing, we can have them come by organizers and show us that they can do it. But of course, on a technical point of view, it's a little bit disappointing. Second thing is, well, we can have a web server and we tell them, okay, once you know which packets you want to send, well, send basically this information on the web server, and if it's correct, you get the flag in return. But if we do that, well, they don't have the part where they actually have to communicate in Bluetooth to the device, and that's a little bit a shame that they don't have that. The third part is, well, I could have tried to grab the firmware, modify the firmware, and then the jump rope will display the flag itself. Except it's just a screen for digits, so you can't display letters very easily. So we could have displayed like lots of numbers, but that's not a really nice flag. And on top of that, whenever you're in a CTF with lots of participants, if you provide a device with a specific custom firmware, you're nearly sure that somebody is going to break it. Okay, so it's not a good solution. So we decided to do it a little bit differently, is to build a fake jump rope. So the jump rope would have exactly the same, I'd say, software or firmware part in it, where it would accept exactly the same commands, respond the same way, and everything. It would behave the same, except you don't have the rope. Okay. So I tried that, and actually it was difficult. I nearly abandoned that because there was lots of BLE projects which were obsolete and which weren't working, or they didn't have exactly the features that I needed, and so I ended up with something which wasn't usable. I was a little bit desperate, and then I went to another Capture the Flag at hardware.io. And they were featuring a challenge, which was also using a BLE device. And I thought, oh, well, the challenge in itself was really different from mine, but the idea was kind of the same, and they accepted to share their code, and it was really just exactly what I needed. So that's basically what I used. I reused their code, reused it, and managed to actually solve the solution and create this fake jump rope. The code isn't extremely complicated. Basically, you say which services you have, which characteristics you have, and whenever you want something to behave in a given way, well, you write the callback for that. And this is what the fake jump ropes look like. Okay, I had a small LCD screen, which actually wasn't really useful, except just to be sure that the thing was still plugged in and running. And I implemented it with actually nearly everything that was on the real jump rope, except the firmware update. The OTA service, because obviously I didn't want it to be updated. And I added another service where people could get the flag. So basically they would have to send the packet saying they are going to jump for that amount of jumps. And once this had been done correctly, I would write the flag in a given characteristic that they could read afterwards. Except we have to kind of protect a little bit the flag, because we don't want this to happen. We don't want a team A to send the packet, then the flag becomes readable, and then team B just happens to be there at the correct time, just reads the flag, is happy, gets the point, but they haven't done anything at all. Okay? The solution to that was actually to limit the number of connections on the jump rope. Only one person at a time can be connected, and then whenever they disconnect or reconnect, I just erase the flag to be sure that somebody cannot inherit from the flag of another team. And that worked. So we had the CTF running during all night. There was like 150 participants, 3 different devices, fake jump ropes, so that several teams could be working on it, but there were many of other challenges, of course. And 2 teams solved the challenge. You can, afterwards, you'll have the slides, of course. You can go and see the write-ups there, so how they managed to do that. And I was pretty happy that they managed to work out the protocol by themselves and communicate with the jump rope. And that's it, actually, for me. So yeah, the idea is just, it's easy to hack, actually, something which is Bluetooth-based, and it's no need to get into really complicated stuff. Most of the time, just look into the app. It will give you lots of hints of how to do and how to hack the device.
All right, thank you. Are there any questions from the audience? None. Oh yeah, okay, yeah.
I'm sorry, maybe I missed it, but for the challenge, you gave the participants the original app, basically, because that worked with your fake rope.
Yeah, so the microphone isn't working extremely well, but from what I understood, oh yes, we gave the participants the application which is on the smartphone, so this one, the real app, and it was up to them. They had access to the jump rope as well, so if they didn't want to do it from the smartphone, I mean, whatever solution would have been correct. The only thing I wanted them was, after that, to be able to initiate the number of jumps without using the app as normally. They didn't have the code of the fake jump rope, of course.
Sure.
Any further questions? Okay, so a little remark from me, like, it's interesting that there was no, like, server-side BLE library that was usable out of the box, because I implemented it for some customer projects. I already implemented a lot of clients to abuse BLE problems, but I never tried to implement the server side, so it's really nice that you now provided us with some resources on that one. Thank you for that.
Yeah. Yeah, that was actually the problem I had with the projects I was looking into. They were just on the other side of what I needed. Yeah. That was why I was so desperate at some point.
Okay, so
Thanks.
Let's thank the speaker again, and yeah.